There it is. Hey guys, how you doing?
Doing all right.
Hey.
Okay. Welcome to, I think this is the sixth episode we've done of Helium on Air, number 006. Today we're going to be talking about home brewing and helium and sensing. And sorry, I was muting something. So I've got two very talented and exciting people with me today. I'll introduce them and then we'll kind of jump into the episode. So I'll start with Andrew Thompson, who is part of Helium, but just briefly by background, Andrew, what's your deal?
I don't know. I do all kinds of different stuff. I was the lead behind the latest element that you'll get when you buy a dev kit. And recently I've been writing tons and tons of Helium scripts. So a lot of the API examples I wrote or I contributed to.
Nice. Yeah, you can find a lot of that stuff on the Helium GitHub repo. And we've got Bryan Fink here, who is our guest of honor. Bryan, I'll let you introduce yourself.
Hey, I'm Bryan. I have known these guys for a few years and have been interested in sensing. Not quite that long, but I've been a home brewer for like 15 years or something. And I like connecting hobbies. So connecting data analysis with home brewing was a fun idea. So I went for it.
Yeah, and you go by hobbyist, which is probably not a surprise.
Yeah, well, there's like two names. I'm hobbyist on Twitter and I'm Beer Riot on GitHub. So
yes, yeah, and the Beer Riot blog is followed by many, as I understand it.
Yeah.
And then I guess for those of you watching who might be students of database history, Andrew and Bryan and I go back to a company called Basho, which is still around, where we worked on a database called, well, I didn't work on it. These guys worked on it. I just got to sit there and talk about it. Where we built a database called Rioc, and yeah, I learned a lot from these guys. I was back in Cambridge, of all places, plus upstate New York for Andrew. Okay, so we are going to talk about helium, and specifically in the context of home brewing. So Bryan has done a lot of really, really cool work over the last month or so, 6 weeks.
Yeah, a couple months probably. Yeah.
Yeah, to take what is the helium development kit or the helium atom development kit and build some sensing into what he's doing for home brewing. And so I'm going to want to have him talk a bunch about that. We're also going to do just kind of a basic a primer on home brewing in general, and then kind of tie it into how the sensing works. We're going to assume that, like me, a lot of people out there don't really know what home brewing is, so we'll spend a few minutes on that. And then if we can, we'll look at some of the code that he wrote to run on top of the sensors. He's got two sensors in particular. One's an accelerometer, and then one is an altimeter that he's built into the brewing setup, in addition to the temperature and pressure sensors that are on the dev board. So let's just jump right into it. So give us the background on how you got into home brewing and kind of what your impetus was for working, sensing specifically this iteration, because you've done it before, into what you're doing now.
Sure. So I got into homebrewing in college. I was living in a house and cleaning out the basement and found two of these things, which is what we call a carboy. It's a giant glass box.
Yeah, okay.
And I emailed the people that used to live in the house and said, I found this. Is it yours? Do you want it back? They said, cool, that is ours. We don't want it back, but you use it to make beer. So I did a little bit more research and figured out how to go from, I have a bottle to there's beer in the bottle, and gave it a shot. And my first couple of batches were terrible. Actually, I think we didn't even drink the first batch because there was stuff that went wrong with it. So it was exposed to air and got infected and all that kind of stuff. But since leaving that house and leaving college and moving into my own place to use my own equipment, my wife likes to say I haven't brewed a bad batch since. So they've all been drinkable. I've only had 2 bottles explode over that 15 years. So I think that's a pretty good record. And I don't know, it's a fun hobby. It's one of those things that it takes kind of a day to do to start and a day to end, and the in-between couple of weeks is something that you don't have to pay attention to it. So you can kind of fit it in around other work schedules and that kind of thing. It's fun.
Yeah. Nice. Okay. And so you showed us that carboy. What is the volume of that?
So this is just over 5 gallons. 5 gallons ends up sitting right about here.
Gotcha. Okay. And then typical for a home brew amount is one of those, 5 of those?
Typical is, there's kind of two classes. Most people will use something that's about a 5-gallon carboy. Lots of people don't use a glass bottle. Lots of people just use a big bucket. You can get a food grade plastic bucket, much cheaper, much easier to clean, all that kind of stuff. But then there's like the second class. There's people that brew 10 gallons. And it's hard to think about, 5 gallons, 10 gallons, like how much beer is that? This basically fills 2 cases. It's like 48 of the standard 12-ounce brown glass bottles you find. Nice.
How do you come up with names for your brews? Is that hard?
Most of them are puns, I gotta be honest. Some play on some, bit of the whoever was brewing it or what is in it or something like that.
Nice.
What's the difference in having a small neck on the bottle versus the lid? Don't you have to isn't there pressure that builds up inside the
There is pressure that builds up inside, and that's what went wrong with my first 2 brews. So I didn't get one out. I have one easy to find here in my bucket of stuff. So this is a standard airlock. This bung fits in the neck here, and then there's a hole through it. You can see the hole, and this sticks in there, and you fill this about half full with water. And basically what that allows is gas to escape, but not any air to come back in. So you're not getting microbes coming into the beer, but pressure can be released because as the yeast eat the sugar, they're going to release carbon dioxide. That's what carbonates your beer. What went wrong with my first brew was that if you fill it to here, and then carbon dioxide bubbles start coming up, it's a very sugary liquid, and it builds up head, just like when you pour it out into a glass. And that will clog that tiny little hole. And then you can't get gas out anymore, so pressure builds up, and you can't actually get enough pressure to build up that this will like shoot off and hit the ceiling with foam. So what most people do instead is they use a tube like this, and you stick the tube in the neck, and then you stick the other end of the tube into a bucket of water, and that will allow the foam to come out of the tube and end up in the bucket of water. And it's still, airlocked, but there's room for more than just air to come out, basically.
That's interesting. Yeah. So I mean, in the process of brewing, what are the things you can sense? Right? What are the things that are throwing off data where you might throw a sensor on there and start to figure out what's happening?
Great question. So what most people are sensing right now is temperature, because the temperature at which the yeast ferments your beer determines a lot of what kind of byproducts they put off and how fast they ferment the beer and that kind of thing, whether or not it actually reaches the fully fermented stage or not. And a lot of people are monitoring temperature such that they can also adjust temperature. So you hook up a temperature monitor to a temperature controller, and then you can appropriately heat or cool the carboy as it's fermenting. What I was trying to sense is instead how far the beer has progressed in its fermentation. So what is normally used for that is basically just a cylinder that you fill with water or beer, and then a known weight with a scale on it. And we call this a hydrometer. So there's weight down here, and there's a scale up at this end. Basically, you toss it in the cylinder, and it floats at a point, and you can read the point. So this is in clear water. So this is reading right now 0 or 1.000. And basically, it's called specific gravity because you're comparing the gravity of the solution to a known quantity, the known quantity being water. As you add sugar to the water, which is what you do when you brew, when you prepare the beer for fermentation, the water produces more buoyancy. Just like when you go swimming in salt water, you're more buoyant. If you were to go swimming in sugar water, you would be more buoyant. So what would happen is that this would float a little higher. So you'd read higher on the scale, and you would say it has a specific gravity of something like 1.050, meaning basically it's 5% more buoyant than water.
Is this the same principle behind those little things you put in your antifreeze in your car to check if you've got too much water in your antifreeze before winter? The little balls that float.
The little balls. Yeah. Yes, it should be the same. And it's similar to that that thermometer that has the little floating glass.
The Galileo thermometer? Yeah.
Galileo is the one. Yes, thank you. Because as the temperature of the water changes, so does the buoyancy. So same idea, yeah.
Does it change volume, or is it a fixed? So what you're saying, as the yeast breaks down the sugar, the density of the water is changing,
right?
And the extra carbon in the sugar is coming off as a gas, and that's going out the airlock, and you're actually losing weight. The water is getting lighter, but it's not changing in volume because the water is the suspension. Okay.
Right. Yeah. The water is becoming less dense, basically.
Okay.
So what I was trying to do with my sensing was basically sense this specific gravity as the fermentation happens. Mm-hmm. Because the standard way to do this is to take what we call a wine thief and stick it in your carboy and take beer out and put it in the cylinder. Every time you do that, you throw away that sample because you don't want to risk reinfecting, you're still fermenting beer. So you lose like 8 ounces to 12 ounces of beer every time, which is, almost a bottle or a full bottle. Mm-hmm. So it's nice to be able to say, I know that the gravity has reached where I want it to go instead of having to keep testing. So that's the idea.
Interesting. Yeah.
How much density do you typically lose over a firm? Is it a lot, or is it a very small amount? Like how precise is this?
So beers can start at basically any density, but typically they start around 5%. So 1.050 would be the specific gravity reading. People start all the way up to about 1.0. Some people start over 1.1 even, so 10% more dense. And you ferment down to somewhere between 1.01 and 1.02. So between 5% and 1%, or 5% and 2%. Usually if you're at 2%, you're kind of in the danger zone because there's still sugar in there that if you put it in a sealed container like a bottle, the yeast is going to continue eating and continue building up pressure.
Right.
So usually you're getting down to like 1.014 or so. And then that basically guarantees the fermentation is almost completed. You can add a little bit more sugar if you want, put it in the bottle, and it will carbonate itself. And
is there a risk if it goes too long, if you take it out too late? I mean, obviously taking it out too early, you haven't got all the sugar out, and it will ferment in the bottle. But if you take it out too late, is there a problem?
Kind of. You still want some sugar in there for like body and flavor. Mm-hmm. And if you take it out too late, all of that will be eaten. In addition,
so there's a specific window you want to hit. You want to nail it. Okay, that makes sense.
Yeah, absolutely. And in addition to the sugar being gone, once the sugar is gone, the yeast go dormant. So it might be hard to actually get the yeast to start up again to carbonate the beer you have.
Right. Is that called bottle conditioning or whatever? When you add the sugar?
It is called bottle conditioning. Yeah, when you put it in there and just let it sit and age. Most of the professional brewers, instead of doing that, well, not most of them, but the ones that don't have live yeast in the bottle do a thing called force carbonating. So you basically, they call it crash cooling because the method for doing it is to chill the beer until the yeast completely goes dormant. And once the yeast is dormant, you can filter it out. You push it through a really fine, small micron filter and filter the yeast out. And then you can just inject carbon dioxide into the beer, just like you would for a seltzer.
Mm-hmm. Makes sense.
Yeah.
So let's talk about the specific sensors that you put on top of the dev kit in addition to the temp and the humidity. So for everyone's reference, what I'm going to do here is try and share my screen so people can see what we're working with here. Can people see that? Yes? Yeah? Okay. So this is the Helium Atom Development Board, for those of you who haven't seen it. So this is kind of the base unit of building on top of the Helium platform. When I take the screen share off, there's going to be a code behind me to go to store.helium.com and buy one of these. So Bryan, you picked up an early dev kit, and you have what, 2 of these, and then 1 access point?
That's correct. Yeah. And
so these Atom development boards are made to take I2C sensors natively. So you can see this 10-pin sensor bus here towards the bottom. So Bryan and I did a little prep before this, and I've got a few of the sensors pulled up here. So you pulled an accelerometer, and which is the ADX L345, and then an altimeter. Let's talk about the accelerometer first. So what we're using this for exactly?
Cool. So basically the idea was, there's another company that has done this as well. The idea is to sense the change in buoyancy by having a float that has different weights on each end. So the idea is, as it becomes less buoyant, one end would sink faster than the other. So the idea is to know your start angle of float, and then monitor the angle as it ferments.
Interesting. Okay. And this was, so I've switched over to Bryan's GitHub repo here. So he's Beer Riot, and then this is the Helium repo, where he's taken all this great Lua code, so it's Helium script, and he actually wrote a lot of really interesting libraries here to make this work. So this, I'm going to want to look at, where can I take a look at this stuff, Bryan?
So I would start with tilt, because that'll give us an idea of the high level of what we're doing. So if you scroll down
where should we start on this?
Basically, right where your cursor is now, the if sensor enable FIFO is kind of the start of things. So this sensor will, it's made to do any sort of tilt sensing, and a lot of people use it in like game controllers because it's quick. It will output readings. It's like hundreds of times a second or something like that. So what I was doing was something very slow. This fermentation takes days, so I didn't need to have, you know, constant updates. But I used their tool. You can set it up such that it will take a bunch of readings and then let you know when it has taken, you know, 10 readings or whatever. So I set it up to use its interrupt controller. That's how it tells you it has the number of readings. I set it up to take 10 readings and then tell me. I would store that somewhere and then wait a minute, and then set it up to take another 10 readings and then wait a minute. 1 minute is by far faster than I needed for this application, but I was curious to see.
It's good. You can collect the data. Why the hell not, right?
Exactly. I needed to experiment. So basically, what this code is doing about line 36 is where I set up the FIFO, the queue of these samples waiting for the interrupt, and then I set up the interrupt right below that. And then at 39 is actually turn on the sensor. You know, this is just, that was telling the queue what it's going to do. Number 39 is start doing that. And then 41 is just waiting for this interrupt to come in.
Nice. And then, so Andrew, talk a little bit about how the HE.interrupt stuff works. Because I know you've used this a lot in some of the stuff that you're building.
Yeah. So, well, first of all, this has actually been we've improved the interrupt in the last release a little bit. There was a problem before where you couldn't set a pull up or a pull down, and some devices would want you to expect you to have a pull up or pull down on your interrupt line, so you get a floating pin and it would just interrupt randomly. But yeah, interrupts basically let you tell the sensor to do some work, and you can go to sleep, and you just leave enough of your CPU awake to watch this pin. And when the sensor says, I've done something, it pulls a pin high or pulls a pin low, and that wakes up the CPU. The CPU now says, okay, I got an event on this interrupt pin. It puts it in the queue, and then in Helium script, whenever you call he.wait, then it will give you anything in the interrupt queue. So basically, when you say he.wait, you can give it like a massive time. You can say, I want to sleep for an hour, or I want to sleep for a day. And unless it's been a day or an interrupt comes through, and then if an interrupt comes through, then I wake up immediately, deal with that interrupt, and then I go back to sleep again. So it lets you, you know, write reactive logic rather than you don't have to pull something all the time. You can set up events to tell you when something's over a certain threshold, or you know, those kind of things. So for example, like in this accelerometer, as opposed to what Bryan did, another thing you could do is you could take the current tilt And then you could set up an interrupt to say, if I see a tilt bigger than this, wake me up. And so every time the tilt increases, you could have an interrupt fire. And then you just set the new threshold to higher than what it is right now. And you'll just keep getting interrupts as it, so if you're getting weird things where it's backing off and, you'll just get the maximum over time rather than having to wake up every 10 seconds and pull the queue. So the interrupts give you a tremendous amount of power and lets you save a lot of power not using the radio, not using the microcontroller, because these sensors typically consume a lot less power. I actually have the bigger brother of Bryan's accelerometer right here. It's the 9-axis. It's got the accelerometer, it's got the gyroscope, and it's got the magnetometer, which is it's a really nice little board. One thing we didn't cover is how the accelerometer actually works. The tilt is detected in terms of gravity. So gravity is always pulling down, and so the accelerometer has a z-axis that's pacing up. But as you get more tilt, that's no longer perpendicular to the actual chip. So the z-axis is like this, but the pull is now like this. So you'll start to get on a flat table at rest, you'll see about 1 G pulling straight down, and as you tilt, you're going to see 0.8 G on the z-axis, and then maybe you'll see 0.2 G on the z-axis, and then you'll see 0.2 G on the x-axis or the y-axis, depending on how it's tilting. And that's how you figure out what your tilt actually is.
Gotcha. Okay. All right. So we got about 10 minutes left here. Let's jump to the other sensor. So we've got the triple axis from our friends here at the breakout board, anyways, from SparkFun. So let's talk about the altimeter module. So Bryan, what did you pull the altimeter for? Why did you integrate this into the Brewing?
So this one was more experimental. No one had done this, and it's kind of not a good idea, specifically for that thing we were talking about earlier, the blow-off.
Right.
When blow-off happens and foam comes out, the volume in the carboy changes, like you lose beer. So the idea behind the atmospheric pressure sensor was, let's put it all the way in the bottom of the carboy such that all of the beer is resting on top of it. And that basically just raises the pressure on the beer, kind of like a submarine, like it's under a lot of pressure under the ocean. So the idea was, as the liquid becomes less dense, there will be less pressure at the bottom of the carboy. So this
sensor, really put this at the bottom of the, how do you put this at the under the carboy?
No, I found an old toothpaste or a toothbrush container, and I shoved the sensor down in here and put a bunch of weight inside so that it would sit down near the bottom. And I had a big cable coming out and then through the blow-off tube and all that kind of stuff.
Very cool.
And there was a nitrile glove wrapped around this so that there was kind of this one end that could flex but was still, sealed. And basically the pressure could affect the air that was still inside. So I needed both that and the pressure sensor that is on the Helium dev board, because the atmospheric pressure changes over the course of the day, as weather fronts move through and that kind of stuff. So I needed to be able to measure both the pressure outside the carboy and the pressure underneath all of the beer, and then, take the difference between the two to see the actual change of just the beer.
So you're looking at a differential pressure.
That you guys pull two of those data sources together. Anything worth looking at in this? I'm on the, let's see here, the sync.lu is where we should be spending our time here for the altimeter.
That is, let me pull it up as well so I can scroll a little bit faster than you and see if there's anything cool in here.
So Bryan, I also saw something about a Hall effect sensor. You want to talk, or maybe we want to cover this first, but I'd also like to talk about that a little bit.
Yeah, let's get back to that in a second. The interesting thing with this sensor is that there's no microchip on this sensor, the MS5607. It's completely analog and just kind of like faking the fact that it speaks I2C. The I2C electrical things that you're sending it are exactly the same as the SPI stuff, and it just happens to work out, basically. But that means that in contrast to the pressure sensor on the dev board, you have to do all of the correction for temperature in your script. So in the MS5607 script, there's some math somewhere. I'll have to find it again.
Get back to that real quick.
Oh, it's in Git reading. It's all the way at the bottom of the file.
All right, let's see here. Yeah, this stuff here.
Yeah, so basically at the factory, they calibrated how the temperature changes the pressure that this reads. So you first have to start up and read this table of coefficients that you plug into this formula that they give you in the data sheet. And then the pressure and temperature that you read out, you feed into this formula, and that gives you what the actual pressure is. So that was the formula. That
sounds like what we did on the BNB 280.
Yeah, it's a similar effect, yeah.
Yeah, sorry, Bryan.
No worries, that's all I had to say.
Nice, okay, and then Andrew, you want to talk about the Hall effect sensor?
Yeah, I saw something about that back in the Slack channel at some point.
The Hall effect sensor is the reason I went down the helium route. So this is a beer bug. This is a commercial product you can buy meant to do exactly this. So this has a circuit board in it, and there's a Hall effect sensor, like right here, basically. It's connected to it's on a little piece of metal that can bend. And a Hall effect sensor basically detects the presence of electromagnetic current, as far as I understand it.
It's magnets. So, it's just magnetism.
How do they even work?
Yeah.
So that metal board is attached to a little piece of fishing twine that also attaches to another piece of fishing twine, and then to this float. And this float you submerge in your beer. And as you know, when the beer is very sugary, it puts less pressure on this board. So the magnet sits very close to the Hall effect sensor. And then as the beer ferments, this has a little less buoyancy to it, pulls a little harder, and pulls the magnet away. So the idea is you should be able to tell how far along the ferment is by how far the magnet has moved away. And when this product works, it's actually, it's pretty amazing. I've measured, I want to say 8 to 10 beers with it. And it took them a long time to get it right, but that measurement turns out to actually be pretty accurate. I found it to be within 2 to 4 points. So 1.002, 0.2% of, density change over time, which is pretty neat. So I was originally going to start with that and ended up looking for the wrong stuff. Most of the time you search for a Hall effect sensor, they have a thing that detects whether or not a magnet is present, not how far the magnet is away.
Yep. So, there are a lot of them are binary. They're not analog. Exactly. They have a circuit in them that clamps high or clamps low, which is really good for RPM counting, which is what I used the Hall effect sensor for the other week. But they do make a few analog ones, but they usually take more voltage to run. Another thing you might be interested in, this is an inappropriate size for what you'd be doing. I don't know if you've looked at a strain gauge.
Not.
This is a 500-pound strain gauge, but the way this works is there's four resistors in a diamond pattern called a Wheatstone bridge, and as you pull on this, the resistors change value under the strain, and there's 4 wires coming out. You put 10 volts into this thing, and then you'll get a very small differential voltage on these 2 pins, and the differential voltage depends on the amount of strain on this. So if you hung you can get them down to like 5 gram sensitivity, right? So you could hang your weight from this, and as the beer is losing density and supporting the weight, the float less, you could in theory be able to see the resistance on the strain gauge change, and you can measure that with an ADC.
Yeah, that would probably work.
Fascinating.
Yeah. So I've been doing a lot of stuff with load cells recently, so I've become an expert on the tricky issue of getting the outputs is in like the nano to millivolt range. So you have to boost it up. There's stuff like I have a gain amplifier here. You can take the very small analog voltage. It also is a nice thing. It strips out common voltage. So if you're powering your load cell at 10 volts, you don't blow up the dev board by feeding 10 volts into the ADC.
Right.
So this thing will go up to 36 volts. So and it's a little part, but yeah, there's a lot of neat stuff where you can take the analog circuitry, condition it down, and then get yourself an actual useful value out of it. Here's another kind of strain gauge, for example. This one you just bend one way or the other. So it's going to similar. You just hang a weight from this end and the flex through these holes. This is the weakest part, and you can see there's a resistor across the top and a resistor across the bottom, and it's the same principle. They work very well. It's another option. We could also do the Hall effect. Now that I've got a bunch of ADC stuff up and running, I just brought up a nice 16-bit ADC, which is a little bit more accurate than the one on the analog board. And it does 4 different channels, so you can actually monitor. You can compare across 2 pins, or you can compare every pin to ground. So this is and it actually has gain built in as well. You can have up to 16 times gain. So if you have a very small signal, you can get it to the point where you can actually see it. So if you want to try a Hall effect sensor, I think we can probably set you up now.
Oh, cool.
Okay, so we are just about out of time. I want to make a couple more, have a couple more questions for Bryan, but shameless plug. So you should go read all the stuff that he wrote about this. You can see it on my screen now. So beerriot.com is the site. blog.beerriot.com is the blog. And he wrote, what is it, 8-part series, Bryan, on this stuff?
Yeah, there are 8 parts to it. Yeah,
so you can see here, this is part 4, and that's the Helium development board with our rainbow cable talking about breadboard, and that's, what is that, the altimeter there, maybe?
That is probably the tilt sensor.
The tilt sensor, yeah, okay. And so he's got all this code here kind of in line. You can see the Helium dashboard, and then these are the carboys. Would you say 5 gallons they were?
Yeah, so the 2 big ones are 5 gallons, and the third one is 3 gallons. And the fun thing about this particular picture is that the reason I was using 3 different sensors is not just that I was interested, but each of these carboys is holding a different type of yeast. So the primary experiment going on here was I brewed 6 gallons of wort, which is what we call unfermented beer, and then pitched 3 different yeasts into 2 gallons each of this. So I was hoping that I was going to be able to understand this data enough that I could tell whether the yeasts fermented at different rates. I was not able to tell that close enough, but it was an interesting experiment anyway, and I did get some good data.
Well, one imagines you'll be doing more of these brews.
Absolutely.
Cool. Okay, so blog.beerriot.com. I also, by the way, did promise Bryan that if he were part of the show, we would get him 1 additional Twitter follower. So if anybody out there has it in the kindness of their heart to follow @hobbyist, do so now, and I will thank you. So, okay, so one last question before we get going. So you are, by all accounts, top 1 or 2% of home brewers in the country of all the, I think you were saying before the show, a couple 100,000 are registered. There's another 800,000 who qualify themselves as home brewers. If you're building a kit from the ground up, and it's going to be on Helium, of course, because what's better than Helium? What are the kind of standard sensors that should be a part of that thing, right? What are the, what is kind of table stakes for adding sensing to a fairly standard brew?
So definitely anything with a thermometer sensor, because it is very important what temperature the yeast is working at. And honestly, if you wanted to go the other route and monitor the pre-fermentation, the part where you're actually brewing and like boiling stuff, high temperature temperature sensing could be cool. Other things that would be interesting are things like fill level sensors. You can do things where you can tell how much volume there is in a container. That could be cool. And then the things that we've talked about, the Hall effect or the strain gauge, sounds like it would be a good idea. I was trying to figure out how I could do something with like a range sensor where you could tell, how high something was floating based on how close it was to your sensor. I think that's
a little bit LiDAR for that, Professor?
The LiDAR currently, the way the LiDAR I tested it's reflected by the surface of water. So you can even clear water in a glass, it can see the interface between air and water. So it can't see something submerged in the water, unfortunately.
Well, as long as there's foam on top of the beer, there's going to be a hard time detecting where the top of the beer actually is anyway.
Yes, yeah. No, you could detect if you had lots of foam.
Cool. Okay, so last question for you. What do we need to improve?
One of the things is that string pop for the 4 to 20 is the same thing, right? It's got that little, it just pulls out the string. So again, you can have your weight on that string.
Oh, right. Yeah, it would just go down as the.
Yeah, exactly. Okay. And that just reads out how much the string has been pulled out. So
nice. So from a development experience, where can we improve, right? So you are a reasonably capable developer. You found Lua generally learnable.
Yeah, Lua I thought was super easy. Like it feels kind of like JavaScript in that you don't have to worry so much about types up front. And most things just kind of work, and you can sit at the console and rerun things and all that kind of stuff with your Helium plugged in. So that part was easy. The API for getting the data is pretty straightforward as far as APIs go.
Did you do that on JavaScript?
Mine is all in JavaScript, yeah. And I didn't even bother with storing on like pulling from Helium Cloud down to mine and then reading from my database. I just pulled directly from Helium, which was easy. Nice. Yeah, okay. I think if there was anything that would have made it even easier is like tools in the dashboard to say, clean up this data in this specific way, just so I didn't have to build.
Yeah, we have some cool stuff coming to the dashboard. I mean, we're trying to walk a line between a general purpose dashboard and something that's more vertically specific. But expect us to see, or rather, expect to see us publish things that will give that functionality, whether it's native to the dashboard or as part of another service that we just incorporate in a variety of ways. Cool. Okay, so we're at about 35 minutes. Andrew, anything else on your mind that you want to talk about with hobbyists here?
No, I don't. Well, I kind of want to brew some beer and see if I can.
But I'm sorry I didn't give you like the whole spiel about how to start from raw ingredients, but maybe next time.
I think maybe when we do the first Helium conference, we'll have you at the venue. You can just be brewing beer. Actually, that'd be really cool.
That would.
If you did a couple, could you brew something in 2 days? Would that work? No, it wouldn't take.
I mean, you could get it to the fermentation stage in 2 days, but it would not get to the point where you could drink it.
Are you still in the Bay Area?
I am, yeah. I'm in San Jose right now.
All right, you should come up.
Actually, we should do a thing in the office where we just kind of get a bunch of beer brewers together to brew beer and do sensing on it. That would be cool. So.
Yeah, we've got a closet. We can tuck it away somewhere. Yeah.
Okay. I'm going to let you guys go, but Bryan, I really appreciate the time here. This has been awesome. And I speak for all of us at Helium when I say thanks for taking the time to not only test the development kit and build some sensing on top of it, but to publish all this work, because I've got people coming to me asking questions about what people are actually building, and this stuff is super useful, and specifically in brewing, people care about this stuff. So I thank you very much for that. Before we go, I want to mention this. So store.helium.com is where you can buy the hardware that we just showed. You can build what Bryan has with 2 development boards and a Helium element access point, and about $40 worth of sensors. If you go now, next week, we're going to give you 20% off of this Brew IoT code. And then all of our documentation is at dev.helium.com. So with that, I will say goodbye to you, gentlemen, and say thanks once again.
Cool. Thank you very much. It was a fun time.